Yes. Very good morning to one and all. Welcome to my EduSite class, 5th class for you all. I think you have remembered what I had taught in the last class. So last thought I have discussed regarding the stress and the strain chapter. In this class we can start with the new chapter that is called Center of Gravity and the Moment of Inertia. It is very easy to score in this chapter for you people, and we have a less number of contents in this and more number of problems in this chapter. So that in this chapter mainly we have to learn what is the meaning of a centroid, center of a gravity and center of a mass and moment of inertia and perpendicular axis theorem, parallel axis theorem and radius of gyration. Let us basically know what is the meaning of the mass. As you all know, mass is the measure of the body's resistance to changes in motion. That means that every body, every particle has its own mass. That means it has some capacity to resist against the motion. It is a capacity to resist against the motion. It is an independent of a particular gravitational system. That means it does not have depends on the gravity, but every material contains some amount of mass. So that after knowing the after knowing the meaning of a mass, we have to learn what is the meaning of the centroid. The meaning of a before knowing the centroid, let us know center of a mass for a system. That means I told already every material contains some percentage of some mass. So that the meaning of a centroid is where actually the mass is concentrated. Where actually the mass is concentrated. That means that in which point it is concentrating. That means that every body, that means that the mass is constant density, and where actually the point is concentrating the mass, that means whole mass, in which point whole mass is acting, that point is called as the centroid. After knowing the centroid, what do you know what is the meaning of a center of mass? What is the meaning of center of mass? Center of mass is nothing but is the resultant force. That means resultant mass. We can't call it as it's a force. We can call it as a resultant mass. I already told at some point the whole weight of the body or whole mass is concentrating. So that the resultant mass at which point is concentrating, that point is called as a center of a mass. That means that it is a point where all the mass is concentrating. In the figure in the first sketch you can see that the CM. We are indicating the sketch that is called CM. CM means it is a center of a mass. So that what is the meaning of a center of a gravity? That's a very important thing, and we have to learn here. Meaning of a center of gravity is where the resultant of the overall mass is acting, locating. I mean that we are locating the center of a mass. We are locating the center of a mass, so that where the whole mass is concentrating, locating the point where the whole mass is acting, we can call it as a center of a gravity. We are locating the resultant. I already told in one or other point, the whole mass is acting. Locating that point, we can call it as a center of a gravity, where the weight will act in the body. So that after by seeing this video, you can understand what is the meaning of actually what is the centroid of the center of a gravity. See, in video you can see that how actually exactly center of a gravity will act. We can see, observe the video here. Where actually the centroid is acting. Here one board is there, he is keeping on the hand. Here one board is there, he is keeping on the hand. Here, see, by observing this video, you can understand what is the center of a gravity. Here, when clipboard is keeping on this hand and you are meant in the center, that means that only that particular point clipboard is not something dancing like that. I mean vibrating like that. Only that point is the board is standing simply that. So that the center which the whole body acts, we can call it as a center of gravity. See, we can find out center of gravity for irregular sections. See, in this board we are located 3 points, that is P, Q and R. P, Q, R. This is an irregular lamina. For this irregular lamina, we are finding out what is the centroid. We have marked the points P, Q, R in this stand. Now we are suspended on some amount of weight. We are suspended some amount of weight, that is called by using some weights. So that after placing the weight, we are marking the plumbing line from the point P.
Repeat the experiment by suspending the lamina from Q.
Now we are rotating the same lamina, and again we are suspending some amount on Q, and same like we are marking the plumbing line.
Mark the plumbing line Q dash. Now follow the same procedure.
Same procedure now we are following to the point R. We are dropping a weight on R. Here also we are drawing the plumbing line on the irregular lamina.
Point R. We observe that all the three lines AB dash.
See, here we can observe that here three lines are crossing each other at a particular point, so that we can call it that point as a center of gravity. So that for everybody we have only one center of gravity. That means that that point where the whole mass is concentrating, that means that the point where the whole mass is concentrating, we can call it as a center of gravity. We can call it as a center of gravity.
Q dash and RR dash intersect at one point. This point where all the three lines meet gives the center of gravity of the lamina.
See, like this we can find out center of gravity for all the irregular section. Here I have given us some examples for wire, scale, sphere, cube and hollow cone. See, we can observe the center of gravity for a wire where actually the stands. That means in wire where actually the center of gravity is standing. See, in the center of a bar, the whole weight of the wire is acting. In scale also we can observe here where actually the center of gravity lies. In sphere also we can observe here. In cube also we can observe where actually, that means that in that particular point whole mass is concentrating. In that particular point whole mass is concentrating. So that I hope you understand the meaning of a center of gravity. I hope you understand the meaning of a center of gravity. That means that where actually the whole weight is concentrating, whole mass is concentrating. So that's a very important factor, because it is a very important factor to determine the center of gravity, because in structure, while considering the structure where actually the center of gravity lies, where it's very important thing. And even for the calculation of moment of inertia also the center of gravity plays major role. See, how to find out the centroid is the very important in this step. Here I already told, here it is given as a four steps are given, that is it has a mass 4 kg, 10 kg and 6 kg. Here how to find out the centroid, that means that where actually the centroid lies. That means here we have to see the two terms, that is x bar and y bar. X bar means it is a distance from the y axis to that particular point, that is called x bar, and the distance from x axis to the point is called as y bar. So that here also we can observe that here two masses are standing, that is M1 and M2. Here particular point only they are balancing. Here only particular point here balancing. That means that if you shift that point CG, I have shown in the sketch, if you shift that point CG, it's very difficult to balance. That means that where actually that particular point the mass is balancing, that point is called center of gravity. See, here the question arises. If the sum of the different, multi-axial masses are placing, different types, different shapes are possible. For different shapes, composite sections also we have to find out the center of gravity. That means that here we are adding the masses. That's a very important thing. We have to take the moments. Here we have to take the moments to find out the centroid. I mean that even some L-shaped sections, I sections, hollow pipes, for many different irregular sections, we have to find out what is the centroid. For that we are calculate the moments of all the sections, and then we find out the moment of, then we find out the meaning of centroid. That means the summation of the moments along each axis we will get the centroid. Here we are find out one x bar and y bar. Here x bar we will get by the ratio of moments along the y axis to the total mass, and y bar we will get moments along the x axis divided by total mass. By solving the problems, we can solve how to find out the centroid of different sections. So that x bar is the summation, I already told, summation of the moments along x axis and the summation along the y axis. So that actually some plane areas where actually the centroid locates. See, here observe one of the first, basically the one is the square. Square exactly where the two meridians meets. In the square, centroid lies where exactly the two meridians lies. That is the centroid. That means it's exactly it's a distance from x axis b by 2 and distance from y axis d by 2. That's very important. In the square, in rectangle also, where the two meridians meets, it is a centroid. In the circle we will get exactly the starting point, that is called center point of the circle, we will get the centroid. See, in semicircle I have shown where actually exactly the centroid lies. That means here I have shown what is the y bar. Y bar here is the 4r by 3 phi. At a distance of 4r by 3 phi, exactly centroid in the semicircle it lies. Here x bar remains as a d by 2. That means the diameter divided by 2. X bar is the diameter divided by 2 and y bar is the 4r by 3 pi. The centroid lies at a distance of 4r by 3 phi from x axis. So for like this same I have shown for all the basic sections. For your solving the problems, importantly you have to know what is where actually the centroid lies for a rectangle as well as a square and as well as a circle. If you know for these three plane sections, you can easily calculate the centroid for all the sections. So after knowing the meaning of a centroid and center of gravity, for the next topic you have to know what is the meaning of moment of inertia. This moment of inertia, this plays a very important role, especially in the civil engineering and mechanical engineering. It's a very important factor. You must know the moment of inertia. Moment of inertia indirectly deals with the strength. Moment of inertia indirectly deals with the strength. So that we have to understand what is the meaning of a moment of inertia. Everybody will say the moment of inertia is the second moment of an area. Second moment of an area is we can define as it is a second moment of an area is nothing but the moment of inertia. But it is the mathematical expression. It is the second moment of an area is the mathematical expression. So that by observing this video, you know what is the meaning of an moment of an inertia. See, here observe in the video you can observe that the meaning of inertia. Here one slope section is there. So in a slope section we are marking the 2 points. In slope section we are marking the 2 points, that is the starting point and ending point. Please observe this video. You know what is actually the real practical meaning of the moment of inertia. Here we are marked the 2 points, that is the starting point and ending point. Here we have weighted some weight, that is called CDs. Here you can observe that here we are fixed the CDs. Here we fixed the CDs to the particular stick and we are made to rolling on this slope section. Here we made roll on the steel section. Please observe the video so that here kept the CDs to roll on this sloping section. Please observe the time to move from start to ending point. Please observe the time taken to roll from starting point to ending point. So that it has taken 3 minutes, 3 seconds, 3.1 seconds. Here we can show that here time taken is 3 minutes, 1 seconds to roll on this plane section. So that after removing the CDs, that means that here we are removing the mass. So that we are removing the mass. Now we are trying to roll only the empty stick. Now we are observing we have to roll only the stick. After removing the CDs, we have to roll the stick on the sloping section. We have to roll the stick on the sloping section. See here, we can observe in the video that it is a time taken to travel from starting point to ending point is very less when we roll. If your time taken to roll on the slope section is very less if you roll only the stick. If it has more mass, the time taken to travel is more. That means that if the mass is more, time taken will be more to roll. That means that we can define moment of inertia is, we can measure the moment of inertia is resistance to change its rotation. That's againstly, that is the capacity. That means that it's the resistance against the rotation. That means that its moment of inertia, we can tell it as it is the resistance against the rotation about an axis. I can clearly say that moment of inertia is nothing but it is a measure of an object resistance. It is a measure of object resistance due to its changing the rotation. See, in the first video we can observe that. In the first observation that if CDs we have tied with the stick, time taken for rotation is more. That means that if you tied the CDs for particular the material, moment of inertia is more. If you removing the CDs, its mass will become less and time taken for the rotation will be more. That means I have less moment of inertia. That's clearly we can say that moment of inertia is nothing but it is a resistance for the rotation. It is a resistance for the rotation, so that the resistance against the rotation we call it as the moment of inertia. So that mathematically we can deal how to calculate the moment of inertia. That's a very important thing. How to calculate the, I already told, moment of inertia is the second moment of an area. It is a mathematical expression. Second moment of an area is the mathematical expression. So that if anybody asks what is the meaning of the moment of inertia is nothing but it is a resistance against the rotation about an axis. You have to say, if anybody asks what is the moment of inertia, you should not say that it is the second moment of an area. You should say that moment of inertia is nothing but it is a resistance against the rotation of the body about any axis. That is called moment of inertia. So that how to calculate the moment of inertia is nothing, means we have to learn here how to calculate the moment of inertia for a particular body. See, I have shown one of the irregular area here. So that is I consider the small element, small strip, that is area called small dA. That is small dA. I have taken the small area. So that's A, exactly the point lies at a distance of x from origin and distance of y under x axis and distance of y from the y axis. So here x1 and x2, x3 are the distances of a small element from y axis. y1, y2, y3 is the distance of small elements from yx axis. So that I already told here see, second moment of an area. Before coming to the second moment, we have to calculate what is the first moment. Here we have to calculate what is the first moment. First moment is nothing but it is a dA into y. It is a y is the perpendicular distance. Here y is the perpendicular distance from x axis. Here y is the perpendicular distance from x axis. So if you multiply by load into perpendicular distance, here load is nothing but an area. Here load is nothing but an area. If you multiply by y into dA, we will get the first moment. If you multiply by y into dA, you will get first moment. Again, the same distance is multiplied by to the area, that is dA into y into, again if you multiply by y, it will become the second moment. That means that here perpendicular distance we are multiplying the 2 times. Here your perpendicular distance multiplied by 2 times, so that is called second moment of an area. So that dA into y square is the second moment of an area. dA square into y square with the second moment area. For one year, dA into y square, it is the second moment only for the small strip. Here dA into y square is the second moment of an area only for small area, that is called dA. Here our intention is to calculate the moment of inertia for the whole body. Here dA is only the small element in this whole body. Here dA is the small strip element. Here dA is the small strip element in the whole body. So that if you apply the integration, if you apply the integration for the whole body, for the whole limits, we will get, if you take the integration from 0 to x, you will get this moment of inertia for the whole body. Here dA into y square is the small strip. If you apply limits, for whole body, you will get, if you apply limits for the whole body, you will get the moment of inertia. Here you know that y square is a distance and dA is the area. The unit for the area, you can already you know that millimeter square, and y square area is millimeter square into millimeter square, that is a millimeter to the power of 4. That is the unit for the moment of inertia. If area and y in centimeter, you will get centimeter to the power of 4. If area and distance in millimeter, you will get millimeter to the power of 4. So that why we have to know that, that's a very important thing we have to learn. What is the practical applications of moment of inertia? Why we have to resist? Why we have to know the resistance against the rotation? That's a very important thing. By observing this sketch, you have to know that why we have to provide the moment of inertia. Here you can observe the steel construction. Why steel elements are placed like this only? Why can't you place it in other direction? That's a very important thing. Many structural members in this steel structure, we know that, like I shape, H shape, channel section, many types of shapes we will use in steel construction. So that which position we have to place, in which position we have to place the I section. So that in many ways we can place, either in perpendicular direction, or we can place in vertical direction, or same element we can place in horizontal direction. So same element we can place in inclined direction. So that the question arises, why we have to place only this position, why can't we change the position? That's very important thing. So that is the major application of the moment of inertia. So that why do usually rectangular circular section areas where actually the maximum area will be lies. So that these design elements, why you have to place in vertical direction or why you have to place in horizontal direction, majorly depends on moment of inertia. That means that in which position moment of inertia is more, we will select the same section. We will select the same position. Section is same. Same section will be placed in horizontal direction also. Same section will be placed in inclined direction also. But majorly depends on moment of inertia. If which position if you keep, then that position moment of inertia will be more. That position we have to select and we have to design the section. Same position in the tubular section. Here the question arises, why we have to use the tubes rather than the solid squares? Why we have to use the tubes rather than the solid squares? It's again the question, it's majorly depends on the moment of inertia. For which section the moment of inertia is more, we have select that section we have to use. So here, how to calculate the moment of inertia, that's very important. How to calculate the moment of inertia for an I section, rectangular section, and as well as the square section. So that maximum possible elements we have to study here. Maximum possible elements. See, you are given as an I section. Why we have to keep the elements in x axis, or why you have to keep the elements in y axis? You can observe in this figure A. I have keep an I section. Middle to the x axis. I have keep an I section that is middle to the x axis. We can also keep this I section in this H position. I also keep this I section in the H position, that means H shape. That means that in which position you keep, in that position the moment of inertia will be more. See, we can also calculate, I already told, I can also calculate moment of inertia for sphere also. I means that irregular sections. I can also calculate moment of inertia for the irregular sections also. If you take, I already told, moment of inertia is nothing but second moment of an area. Moment of inertia is nothing but second moment of an area. That means that here also we are calculating the small strip, that is a dA. Here also we are calculating the second moment of an area for a small strip, that is dA, into y square. Here y square is the perpendicular distance. If you integrate the section by applying the limits for the whole body, here apply the limits for whole body, you will get the moment of inertia. By observing the video, you can also understand again the meaning of the moment of inertia. See, here we can observe the video, that is one side is the wheel and another side is the disc. Here both are revolving. Here both disc as well as wheel are rotating on the same axis. You can observe, you can observe the meaning of the moment of inertia. Here I have taken in this video wheel and the disc. One wheel and the disc. Both the wheel and the disc are rotating in the same axis. After rotating, we are trying to stop this wheel and the disc on the same hand. Here the mass is same. Here mass of the wheel is same and as well as the mass of disc is same. Here the mass of the wheel is same as well as mass of the disc is same, but it is very difficult to stop the wheel compared to disc. Here the question arises, why it is very difficult to stop the wheel when compared to the disc. The solution is, you can observe here. See here, see disc is stopped and again the wheel is rotating. We are, in this case already disc is stopped, but we are trying to, it is very difficult to stop the wheel. That means that the force required to stop that wheel, required to stop that wheel is of an object is, that is mr square. That is mr square. Your mass is nothing but an area. I taken an example, I already told, your mass is nothing but dA. Your mass is nothing but small dA and r square is the perpendicular distance. Your perpendicular distance is the radius. Your perpendicular distance is the your perpendicular distance is the radius. Your mass m is the dA. dA into, I told already in the last slide, dA into y square I told. In this case m into r square, the meaning is same. So that it is a product of mass into r square. The force required to stop the rotating object. Force required to stop the rotating object is nothing but what? It is the moment of inertia. Force is required to stop the rotating object is the moment of inertia. I already told it is the resistance for the against the rotation. Resistance against the rotation is the moment of inertia. Here force required to stop the rotating object is the moment of inertia. In the last slide I showed dA into y square. Here I am telling m into r square. The product of mass into r square. Mass is nothing but small dA and r square is the perpendicular distance. Here by observing this wheel, you can notice that here many masses is there. So please observe the video. Here still wheel is rotating, disc is already stopped. Here mr square, it's a very important distance there, very important thing here. mr square, force required to stop the wheel is greater than force required to stop the disc. We can observe here, force required to stop the wheel is more than the force required to stop the disc. It's because wheel has, it's because, again observe the video, still wheel is rotating, wheel is rotating, mr square in the wheel is more than mr square in the disc. I already told mr square is the moment of inertia. Mr square is the moment of inertia. That means that moment of inertia of the body is m1 r square plus m2 r square, means it depends on number of masses. Wheel has number of more spokes, wheel has number of more scopes, so it producing more number of masses. It's producing more number of masses. So summation of all the masses you can show in the figure. See, there's a particular point, more masses will be acting. More masses will be acting at the point, so that if it summation of all the masses, if you do m1 r square plus m2 r square plus m3 r square, if you add all the masses, you will get total moment of inertia. That means that moment of inertia is more for the wheel compared to the disc. I hope you understand the meaning of the moment of inertia. I hope you understand what is the meaning of moment of inertia. So that I hope you understand what is the meaning of inertia. Same point we can calculate the moment of inertia for all the irregular sections. Here we are taking that smallest strip area and we are multiplying the perpendicular distance and twice, so that it will get second moment of inertia. So that if you apply the integration for the suitable limits, we will get the moment of inertia for the whole body. So that let me know, I already told what is the meaning of a first moment, and so that we can calculate by using the first moment, we can calculate what is the second moment of inertia by multiplying the distance. I already told about this. So that let me discuss some of the examples how to calculate the moment of inertia for a rectangular shape. So that I will discuss only I will discuss one for one plane section, so that by applying the same method we can do the moment of inertia for the whole section. See here I have selected the rectangular section. Here I have selected the rectangular section. It's placed about the central axis. It is placed on the central axis. Here ZZ axis is the central axis. So that here I have taken the only small strip, that is dy. Here taken the only the small strip, that is it has taken the small strip, that is dA. That means I am taking only small area, small amount, that is dA area. Here dA is nothing but length into thickness. Your small area is length into thickness. So dA is B into dy. dy is the thickness of a small strip you have taken. In red color I have shown in the figure, in the rectangular body. In the red color I have shown. So that for only rectangular section, that is red section, small strip you are calculating the area. That is, if you multiply by dy into B, you will get area of small strip. If you multiply by width of B into dy, you will get small strip, that is dA. So dA here B into dy, here perpendicular distance is, here you have to observe here perpendicular distance is y square. Here perpendicular distance is y square. It is a second moment, that means it is y is the perpendicular distance. Here y is the perpendicular distance, that is called y square. Here we are applying the limits from bottom to top. We can observe here limits is, I have done, it is placed in the central axis. Here applying that small moment of inertia y square into dA, we are applying for the whole body. That means here minus h by 2 to plus h by 2. That means that from bottom point to the top point we are applying the limits. If you integrate that, y square, you will get y cube by 3. If you integrate that y square, you will get y cube by 3. So if you apply limits, you will get moment of inertia of a rectangular section about an x-axis. Here because the element were placed along the x-axis, so that you will get the moment of inertia along the x-axis. That is because I told already here x-axis is nothing but here I have shown the z, so that I am showing that Iz. Here Iz is bh cube by 12. Here moment of inertia about an x-axis is bh cube by 12. In the same way, if you apply limits for all the sections, you will get moment of inertia for all the actions. So that's one of the very important factor. I already told I value is an important value. It depends on how we are placing. I already told how we are placing the section is very important thing. How the section is placing is very important thing. Here, see, here we can observe here h height. Here two values are there. One is B and one is h. Here one is B and another one is depth of the section, where B is the breadth of the section, width of the section, and h is the depth of the section. Here B is placed on the x-axis. Here B is placed on the x-axis. If you place on the x-axis, you will get bh cube by 12. If you place B on the x-axis, you will get bh cube by 12. Same section if you rotated. If the same section is rotated, that means if you place the section, if you place h on the x section, if you place h on the x section, you will get Iz is equal to b cube by 12. hb cube by 12. That's why I said in the starting itself, how the section we are playing is very important. How the sections we are placing is very important thing. So that you can observe in your classrooms that maybe if beams are placed in your classrooms, that you can observe why beams are placed like that only. In any case, we can see that beam depth will be more. Beam depth will be more and width will be less. Beam depth will be more and width is less. It's because of the moment of inertia. It's because of the moment of inertia. If you place that, if you place the for same position, in that position, you will get more moment of inertia. So that please if you can observe these sketches, if moment of inertia is bh cube by 12 is more than hb cube by 12. So that beams we have to place in the first section only. It's like the first position only. Like the first position only we have to place the beams. That's why depth will be always be more. Depth will always be more. If you place it, if depth is more, moment of inertia will be more. So that means that against the rotation, the resistance will be more. So what about it's a very important thing. If I have told for calculating the if you calculating for a simple section, I mean plane sections is very easy. So that how to calculate for the built up sections, how to calculate the moment of inertia for the built up sections is very important thing. Here we have to calculate. Here we have to use the one of the transfer formula. Transfer formula means nothing but we can find out the moment of inertia for different axes. That is called by using parallel axis theorem. That is called parallel axis theorem. In parallel axis theorem we can call it as also transfer formula for built up sections. For built up sections we calculate the moment of an inertia. See here we can observe, here I have used the T section. Here it depends on the first position rectangle is different and second position rectangle is different. First here two portions are there. One is the flange portion, that means top of the T section we can call it as a flange, and the depth function we can call it as a web. Here placement of a depth is different from placement of a flange. So that for built up sections, for this type of sections we have to use the parallel axis theorem. See, in the first case we are calculated what is the moment of inertia. What is the moment of an inertia about the centered axis. In the first step we are calculated what is the moment of inertia we are calculated along the centered axis. In this parallel axis theorem we are calculating the moment of inertia for different type of axis, so that how it will be resistance along the x axis and how it will be resistance against the y axis, very important. So that see you can observe, in this case we are calculating the moment of inertia for an axis a dash. You can observe in the sketch, we are calculating the moment of inertia along the a dash axis. So for this case how we have to find out the moment of inertia, that's very important. Here the concept is also same. Here also we are taking the y square into dA. I already told what is the meaning of a y. Y is the perpendicular distance. Here y is the perpendicular distance. In this case some additional distance will be added. In this case some amount of extra distance will be added. See that in this case perpendicular distance is d plus y bar. Here perpendicular distance is d and y bar. It is a perpendicular distance for the only the small strip. I am repeating again and again. Here for the perpendicular distance is the d plus y dash. If you square, it is the second moment of an area. If you multiply by that perpendicular distance, it is the second moment of an area. In the first case we are taking perpendicular distance only y. In this case, because in this case we have shifted the axis. In this case we have shifted the axis, so that axis with reference to that axis we have to take the perpendicular distance. So for this axis we have taken the distance is d plus y bar. If you square it, you will get the second moment of an area. If you integrate the section, we will get I is equal to I bar plus a d square. If you integrate that, we will get the final equation. Moment of inertia about a dash axis is moment of inertia of the central axis plus a d square. Here I bar is the moment of inertia about the central axis, that is meant it is for the b dash axis. If you apply the parallel axis theorem, we will get the moment of inertia for any axis. I is equal to I dash plus a d square. So in the same way, what is the meaning of the perpendicular axis is very important thing. Perpendicular axis theorem. What the perpendicular axis theorem says? Perpendicular axis theorem says moment is the summation of, perpendicular axis theorem says that it is the summation of moment of inertia of along the x axis and the moment of inertia along the y axis. It is the perpendicular, what is the theorem says is, it is the moment, it is a value. The perpendicular axis theorem says it is the summation of the moment of inertia along the x axis and the moment of inertia along the y axis. See, I have shown for the some elements what is the moment of inertia. For rectangular section I have shown BDQ by 12, already we have derived. In the same way we have to know here for triangle section. For triangle section the moment of inertia is BHQ by 12. See, for rectangular section I have shown BHQ, but in which axis how the moment of inertia will be. In the first section, if you take along the x axis, it is a BHQ by 12. If you take along the x axis, y axis, it is BHQ by b cube into h by 12. For different sections, different axes I have shown the in this sketch. So another important concept here, what is the meaning of radius of gyration? Another important concept. So that what is the meaning of a radius of gyration? That's radius of gyration is nothing but it's a distance from in which axis we are taking the moment of inertia. In which, what is the distance exactly where exactly the actual object lies. See, for a given area, the moment of inertia I axis, let us imagine for a given strip, that is I shown in the green color, for that section the moment of inertia is Ixx, and where the entire area is located at a distance of Ks. That means that it is exactly moment radius of gyration means it is exactly where the object is lying. Where it's radius of gyration is nothing but it is a distance where the object is lying from the axis. If it is a distance of the object from the axis where actually it's lying. That means that here exactly Kx is locating the object from the axis. It is exactly the where locating the object from the x axis. So that how to calculate the Kx is very important. It is a square root it's a square root of Ix divided by A. It is the square root of Ix divided by A. It is a distance from, you will get x axis. If you same thing if you do if an Iy divided by square root of Iy divided by A, you will get distance from the y axis. If you take, it's I already told radius of gyration is nothing but we are locating an object from the axis. You are locating the object from the axis. So that how to calculate the radius of gyration is nothing but already we know how to calculate the moment of inertia for different section. So that Kx is equal to square root of Ix divided by A. You will get the moment. It's a distance from, you will get distance from x axis. If you do the square root of Iy divided by A, you came to know how to locate from the y axis. So I already told that the square root of Ix divided by M, and Ry is the root of I divided by M. So in this class we have studied about the theory, what is the meaning of the centroid, what is the meaning of the centroid, center of gravity, and I discussed about the center of the mass, and we have discussed about the what is the meaning of the moment of inertia. When we discussed about the parallel axis theorem, we discussed about the parallel axis theorem, and we discussed the perpendicular axis theorem, and we discussed the radius of gyration. So that in this chapter, in this now again we have to solve some problems regarding how to locate the centroid. How to locate the centroid we have to solve in this session. So let us take the one simple example. Let us take the simple example for locating the centroid. Here we can take the one small section, that is for any L section we can take. See, in this chapter you have to know for how to study the sections. In this chapter we have to know how to study the sections. That is, here we will study about the L sections. Here we will study about an L section. See, this is called, we can call it as an L section. This is, we can call it as a L section. This is, we can call it as a L section. See, if you take in this chapter we will study also T sections. See, this is the T sections. So this is the T section. This can we call it as a T section. So again this is the L section, this is the T section, and if you take the I section, this is the I section, this is the I section. So you can study even a channel section also. We can study the channel section. So we have to know the meaning of these sections. If you know the meaning of this section, so you see this is I section, this is I section, this is channel section. See, this is L section, this is T section, this is I section, and this is channel section. See, sometimes what will happen in the exam is, sometimes they will give the problems by theory. So that by using this theory, we have to write the sketch. So that, see, in this T section, we can call it this is as a top flange. We can call it this as a top flange. We can call it this as a top flange. After this means only this portion we can, this is the top flange and this is the web portion. This is the web portion. So that this we can call it as a web. Shaded portion is the web portion and the top one is called it as the top flange. See, by in I section we can easily look at, see, this is the top flange. This is the top flange. See, in what happens in problems, they will directly give what is the dimensions of the top flange and what is the dimensions of the web portion and what is the dimensions of bottom flange. So this is the top flange and this is the shaded portion, we can call it as a web. See, shaded portion we can call it as a web portion. Shaded portion we can call it as a web portion and bottom, this is called bottom flange. So bottom portion, this is called bottom flange. This is the bottom flange, this is the top flange and this is the web portion. This is the web portion. So that in this case this is the top flange. In this case this is the top flange. This is the top flange. This is the top flange and this is the bottom flange. This is the bottom flange. So this portion is called web portion. This portion we can call it as a web portion. So we have to know the meaning of the every section. So this is the L section. Here both only the flanges, the directed dimension will be given in this. So here this is the L section, this is the T section, this is the I section and this is the channel section. So by observing the theory, we have to write the sketch and dimensions of each unit is very important. See, now we have to calculate, in the first problem we have to calculate see, in this first problem they given us, we have to calculate center of gravity, that means CG. In this first problem we have to calculate CG. So in this given section is 90 mm, 120 mm into 12 mm and it is given as L section. See, in this problem only given as the dimension of a section. Here only given as the dimension of the section and here named section as an L section. For this section we have to find out what is the center of gravity. We have to find out for the L section what is the center of gravity. So before starting of the problem, you have to write the sketch of an L section. See, here given as a 90 mm. Here given as a 90 mm. That means here first element is the base. Here first element is the base. So first you write it is a 90 mm. First you have to write the base portion, that is called, this is 90 mm. 90 mm and the second portion is the depth, that is second portion is the depth, that is called, this is 120 mm. This is 120 mm. 120 mm. This is 120 mm. 120 mm and here given thickness as a 12 mm. 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 That means that for this section we have to calculate what is the center of gravity. That means that for this section where actually the mass is concentrating. For this section where exactly the mass is concentrating. That means that which point the whole weight is acting, that's in this problem we have to locate here. Suppose let us imagine if the point is this. If suppose this is a CG where actually this point is there. That is our intention, is to calculate what is exactly the CG. Where actually exactly what is the CG. If suppose let us imagine this is the distance we have to calculate. This is the distance x bar we have to calculate. X bar is the distance from the y axis. X bar is the distance from the y axis. X bar is the distance from the y axis and y bar is the distance from the x-axis. This is now our intention is to calculate this point. That means that what exactly distance from the x-axis and what exactly the distance between the y-axis. Our intention is to calculate what is the distance from the distance, what is the x bar and y bar. So after marking this point CG, now we have to find out an x bar. Now we have to find out, first we have to find out what is an x bar. What is an x bar? See, I already told x bar is the a1 x1 plus a2 x2 divided by a1 x1 plus a2 x2 divided by a1 plus a2. I already told in the theory it is a total mass, that means summation of mx divided by summation of mass. Here m is nothing but mx is nothing but total area. Moments of an area, it is a total mass, that is total area, that we can call it as summation of ax divided by a. Ax divided by a. Why I have taken only a1 x1 plus a2 x2 means here we can divide this into two elements. Here we can divide this into two elements. So this is the element number 1. So this is the element number 2. It is like just like it is also built up section only. It is also built up section only. So that here we are dividing the areas into two portions, that is portion number 1 and portion number 2. Portion number 1 and portion number 2. That's why I use a1 x1 plus a2 x2 divided by a1 plus a2. Here, so that first this is the x bar and y bar is a1 y1 plus a2 y2. a1 y1 y1 plus a2 a1 y1 plus a2 y2, so that a1 plus a2. See, if you substitute these values in this equation, you will get what is the x bar and y bar. So before substituting, we know actually what is the values of x1 and y2. So if you understand one problem, you can solve the other problems very easily. Now we have to know what is the values of x1 and y1. See, first I am taking the element 1. First I am taking element 1. First I am taking element 1. So thus in this element, first I have taken this is element 1, we already know that, we already know that. Now in this element, it is the actually what is the x1 and y1 means, see, for this rectangular section where I have told centroid exactly lies at the centers. That means that this point, this is the centroid for this point. That means total length is, here total length given as 90, total length given as 90 mm here, exactly light at the center. That means that 90 divided by 2. This distance is 90 divided by 2. This is x1, we already know. 90 divided by 2, this is the x1, we know. That means that it is the centroid of the first unit. It is the centroid of the first unit. So x1 is equal to 90 divided by 2. So it is, you will get 45 mm. This is the x1. This is the x1. And what about y1? See, this is the y1, we already know. The centroid from the x-axis, that is called y1. The total one is with 12 mm already we know. Total depth is 12 mm we already know. So that y1 is equal to 12 divided by 2, we will get as 6 mm. We will get as 6 mm. See, here we are marked the CG of the first element. We are marked the center of gravity for the first element. In the same way, if we mark the centroid of the second element, see, write its second element like this. See, where actual axis is? See, this is x-axis, this is y-axis. Now, where actually CG lies? CG of this block lies this point, because see, the meridians are joining here only. See, meridians of this block, rectangular block is joining in this place. So this is the CG. We have to mark this point. See, this is what? See, this is y2. That is means this is second element. Here what? This is the y2. Total distance is 120. Total length is 120. Here distance is, in this distance is 12 mm. 12 mm. So that actually where y2 get is, here y2 is equal to, see, this distance is 120 divided by 2, because exactly lies at the center. 120 divided by 2. See here, y2 is 120 divided by 2. 120 divided by 2 plus plus here we have to make it note that we have to add this distance. We have to add this distance because we are finding the centroid through the x axis, so that 120 divided by 2 plus 12 mm plus 12 mm you will get y2 as 66 mm. You will get y2 as 66 mm. See, here one thing you have to make note that here total length given as 120. Here total length is given 120. Here we are reducing the thickness. So that this becomes 108. So 108 divided by 2 plus 12 mm. 108 divided by 2 plus 12 mm, you will get 66 mm. 66 mm. 66 mm, and this is the y2, and x2 is, see, this is the x2. That is 12 divided by 2, that is 6 mm. You will get yx1 and y1 and x2 and y2. If you substitute these values in the above equations, you will get, see, x bar is a1 x1 plus a2 x2 divided by a1 plus a2. And a2. See, a1 is the area of first unit. A1 is the area of first unit. You know what is the area of first unit? 12 into 90. And a2 is 108 into 12. Area of first unit is 12 into 90 and a2 is 108 into 20. You will get a1 as 1080. You will get a1 as 1080 millimeter square, and a2 is 1296 millimeter square. If you substitute these values, you will get x bar as 23.73 mm, and again y bar is equal to a2 y2 plus a1 y1 divided by a1 plus a2. If you substitute the values of y2 and a1 and a2, you will get y bar as 38.73 mm. Now we have to locate these values in the sketch. That means that this is 120, and this is 90 mm. See, this is x bar, this is 23.73, and this is y bar, this is an x bar, and this is y bar is 38.73. This is the CG of this L section. That means that this point, whole weight of the body is acting. Okay. Thank you for seeing my video, and we can continue in the next class.